过去，我想。Now we have, this is the problem I gave in the homework last week. And it is like this. Sorry. And this is A, B, C, and D here. And we have, this is 20 degrees, and this is 0.15 meter, and this is 0.1 meter. And you know it is in the textbook, and you can look at your homework, and you can see the. And we have 1 force to 200 newtons here, right? Anybody haven't seen this before? So you have seen this in homework, right? You have seen this in homework. Now, and I want to. So we draw the free body diagram of this this structure ABC, ACB. Now, and what do we need to determine? We need to determine tension in cable, AD, and reaction at C, right? This is a question. Of course, in the homework, I only ask you to draw the free body diagram, but it needs, we want to determine these two: tension in cable AD and reaction at C, right? The next, now it means let me write info. Let me mark them here. So we need to determine this tension and the support forces. So how do we draw the free body diagram? Now, and may I go back? I will come back to here in a minute. Let me go back for a second. Here, for the forces we need to determine, they need to be on the boundary of free body, okay? They need to be on the boundary of the free body. That means our boundary, the boundary of our free body needs to be here and here, okay? And of course, we have an external force acting on the lever. It's okay. So the free body is the area I mark here. Now so there are three things in the free body diagram. The first one is contour, and mark all the points. And that is points B here. And because the boundary of the free body is here, so I will draw it like this. And that's the first thing. The second thing is the contour of the free body, and then we come to the second part, the external forces. For the external forces, we have 200 newtons here. Right. Now, and we have, do I have forces do we have external forces acting upon C? Do we have external forces acting upon C? This is a pin support. So for this support, can we move into the left and right? No. Can we move up and down? No. Can we rotate? Yes. So we have two forces here, CX and CY. Now, and for point A, and point A is the cable, so we have one force here. This is T. Okay. And then we mark the. These are all the external forces acting on the body. And last we have 20 degrees, and we have this 0.15 meter and 0.1 meter, and then we have 0.12 here. Now this is our free body. This is our free body. This is one way of this is the one way of doing it correctly. Okay. I would say the basic way. But we have another way of doing it as well. Now, and of course, from this from here, how many unknowns do we have? How many? 3. CX, CY, and T. And of course, you can solve it by summation fx equal to 0, summation fy equal to 0, and summation f equal to 0, right? Of course, you can do this. This is the basic way of working on this question. But we have another way of doing this problem. Let me copy this figure. And sorry, let me put it this way. Can you see clearly? Now, and let me go back to let me remove the forces here, and remove the forces, and I will explain what we can do. Now we have the same one, right? We have learned about 2 force bodies and 3 force bodies. 2 force bodies and 3 force bodies. And let me go back to page 41. So we have 2 force bodies and 3 force bodies. And 2 force body means external forces act on 2 points of the body. And 3 force body means external forces act on 3 points of the body. Now, okay. Is it a 2 force body or 3 force body? Let's look at the problem here. The external forces act on points A, point B, and point C. Right? So all forces, we have 4 forces, right? We have 4 forces. But they all act on 3 points of the body. So this is a 3 force body. Is that okay? We have 4 forces. Of course, we have T, we have CH, we have CY, we have that 200 Newton. But they act on only 3 points of the body. So it is a 3 force body. Now, what do we know about 3 force bodies? free force bodies and free force bodies. Sorry, I'll come back to the point. The lines of action of F1, F2, and F3 would intersect at the same point. Now we use this as a let's talk about this thing. Let's talk about this problem. We have this 200 newtons, right? This is given. And for the cable, we have tension T here. Because it cannot go, this is the only direction it can go, right? It cannot go this way. It cannot go this way, right? It can only go in the direction of the cable. So the lines of action of these two forces are no. Here. Not very good. Here. So of course we in this in our last in this in the upper free body diagram we have a Cx and Cy and the resultant force is for example is here. But in reality, we cannot, this cannot be the correct direction because the resultant force as C will have the same, will have the line of action going, for example, here, point E here. So the force as C will only have in the, it can only be in this direction or in this direction. Okay? It can only go downwards to the right or go upwards to the left, but it has to be on the line CE. Is that okay? So if I were you, I will write FC here. So this is also a free body diagram. It's okay. Of course, you can. Of course, now we have this. We need to determine this angle beta or unmixed flux. We can work it out from the geometry. It's okay.